Hi, and welcome to today's online SpecDD training session. My name is Charles, and I'll be your instructor today. Today's SpecDD session is going to cover quality. SpecDD typically, uh, similar to many other agile methodologies, is developer-centric. But SpecDD is also quality-centric, and this is where it differs from other agile methods. The QA process is just as important as the development process. So some of the basic terminology we'll use in SpecDD concerning quality. For those of you familiar with testing or QA, some of these will definitely be familiar. We have our quality artifacts of test cases, release plans, test cycles, and quality trend. Now, quality trend might be the only one that's a little bit confusing, and we'll cover this later in the session as well. But simply, the trends that that are usually used to compare quality, meaning how many defects have been opened, have been closed. You know, the trend over a specific testing cycle. So now I'll start off with our diagram, which I'm sure many of you have seen multiple times now. This one's a little different because it is our QA process diagram. Now, everything comes in the same way, epics, specs, we go into our stories, but the areas that we're going to focus on today are on the right side. So we have our testing library. Okay? You'll notice that this, of course, is inputted from our requirement space. We go directly from our specs, from our epics, to our testing library. Our test cases are derived and created from the original requirement. This allows for a very straightforward and direct way of creating these test cases without any interruptions in the middle. So there's no chance of the original idea or the original thinking being confused or muddled before it gets to our QA team. The QA team is responsible for creating these test cases to test the requirements. And they'll test them, they'll run through the test cases that they've created in their QA cycle. Now the QA cycle in the lower right, this cycle, the input, is the working software. So this working software is what's delivered by our development team. Now, once this cycle begins, very similar to our development cycle beginning, we can still allow for change inside these cycles. So test cases can also be dynamically created while we're already in a testing cycle. And we'll discuss what exactly the working software input is, if it's a one-time deal, if it's at the end of every sprint. We'll discuss that a little bit later. The output for the QA cycles are inevitably defects or bugs. After testing the working software, I have never seen a defect-free piece of working software. So after testing it, the QA, with their defects found, will submit those back to the product backlog. They do not go directly into the next sprint. Once again, the defects do not get automatically put into the next sprint. They need to be put into the product backlog so that the product owner can then review and reprioritize them for future sprints. It may be the next sprint, or it may be the following, or it may be 5 sprints down the road. And it's also possible, if the product owner reviews it, discusses it with the stakeholders, that this defect they can live with. Okay? So those are how the defects get handled. Okay. So again, following our diagram, we have a written out list of our test release plans and cycles. So these are our different spaces. So of course we have our spec space. That's the input for all the items. From our specs, our QA team directly creates the test cases, and they're linked directly as well in our DevSuite tool. These test cases are meant to test a specific deliverable from the development space, that being the working software. So you'll see a little roundabout, you go from the test library to the development space, and from the development space, you come back out into the test library. This indicates that the test cases can and will be updated based off of the working software. You then also have your regression testing. Your regression testing is just that. Once working software has been delivered, the QA team is responsible for going back and testing past functionality. So once again, we take our input from the test library, since those are where the test cases come from. We test through our testing cycles, and any defects found are put back into the product backlog. And for the end product of the regression testing is our final release for that period. So an example here of our test cases. Test case templates define the test procedures. So they indicate what the steps are needed to be in order to complete the test. And then they'll also list the expected results. So if I run steps A, B, and C, and everything is working 100%, then this is what I expect to see. Test case templates can be associated with test scripts for automated testing. Our DevSuite software tool integrates with a few automation testing software. This way you can definitely cut down on the redundancy and increase the efficiency of the software that you write. You simply run the automatic testing after every new build. Test templates are linked directly to the requirements, specs, and epics. Again, we keep track. Helps provide that total traceability throughout the entire life cycle of your developing. So the test templates are linked directly, so if you do need to check back to view the original stakeholder or product owner's intent, you can fairly easily do that. And then in general, a set of test cases is meant to cover all aspects of testing. So we want to make sure that we cover all of the areas for that sprint that we developed for. So a quick training question. How are test cases created and improved? Test cases, how are they best created and improved? Product owners create requirements and they define the associated test cases? Or do the story owners review the story and create the test cases? Maybe the programmers help to create and improve the test cases. Or is it the QA test team themselves that review requirements and define test cases? And lastly, the QA floaters, are they the ones that review stories and create test cases? This is a pretty easy question, so unless you've been asleep for the last 5 minutes. Obviously, the QA test team is the one responsible for reviewing the requirements, the specs, and defining the test cases. Now, the QA floaters could potentially help improve those test cases, as well as the programmers themselves. But the initial creation, the bulk of it always lies with the QA testing team. So the test coverage for a sprint, as outlined here, let's quickly go through it. For each story, we can find out the linked test cases. Now remember, a story is in the development space. A story is already inside a sprint. But let's say we want to figure out which test cases are associated with that story. How will we do that? Well, the story is linked to a spec, since that is the instantiated copy of that spec. And then from the spec, we can find out which linked test cases there are in the test library. Similarly, for each defect, we can link and derive those links to find the related test cases. Okay, so each defect is linked to a test case, since the test case is what is run in order to find the defect. And lastly, for the coverage, we can generate all the test cases required for the testing of that sprint very easily. And this is because of the total traceability that we have within our DevSuite tool. The links provide the necessary information. We know that in this sprint, we have these stories. We know that these stories are linked to these specs, and we know that these specs produced these test cases. So within 2 steps, we can run up a report that gives us all this information. So testing for the current sprint. Now some of you may be wondering, what? I thought the QA team is the one that does the testing. Well, in SpecDD, we do have a little bit of testing thrown in for the development team. And that's because within our development team, we have 1 or 2 QA members. And these are the QA floaters that should join the development team from the QA team. These QA members, these QA floaters help not only to test within the sprint, but they also help developers to start thinking in more of a quality-centric style of developing. You know, without these QA floaters, a developer runs through his code, he creates it, he sends it off. He thinks he's done. If there are any bugs, don't worry about it. QA will catch them, and then next sprint cycle, I'll just get it back and fix it. That wastes time. So with these QA floaters, checking their code, verifying it within the same sprint, a developer won't be able to think like that, and they shouldn't. They should think when they're writing the code, let's make this as high quality as possible. Let's finish this with minimal amount of bugs so that we don't have to come back to this piece of code. So that once I finish it and QA floaters are done with it, I can send it off knowing that most likely it will not be returned to me. So that's the testing within the current sprint. And we want to make sure all these developers perform enough testing to ensure development quality. Now, these test results may affect the time remaining because they may increase a developer's time spent on a particular task. But time spent here is kind of an investment, an upfront investment. If they wait until the next cycle, when the bug finally comes back, even more time would be wasted. So it's better to spend the time now, get it right, instead of having to do it multiple times. And lastly, the burn down report should reflect the development and the quality effort. Let's take a quick break and answer question number 5 on our training polls. What is true for regression testing for the current sprint? Regression testing better protects the current sprint quality? Or maybe should defects found be fixed by the current sprint, within the current sprint? Should regression testing start as soon as some tasks are done? Or should regression testing be performed automatically, as well as manually, both, for the current sprint? Okay. So the first answer choice, regression testing better protects the current sprint quality. And it's a little iffy, because regression testing may not occur right when the sprint finishes. Now, most may think this, right? Most people consider regression testing when this sprint is done, boom, I'm starting my regression testing right away. But that's not always the case. Regression testing may be 1 or even 2 cycles later, or even more. Answer choice 2, should defects that are found be fixed in the current sprint? That should absolutely not be mandatory. Defects found should not go into the current sprint. It should not delay the current sprint to fix defects unless it is really considered a showstopper. Defects found should not even be mandatorily fit into the next sprint. Okay? Right? Where should defects go? Defects should go back into the product backlog in order to be reviewed and reprioritized by the product owner. Then they will determine which sprint those defects get placed into. Regression testing should start as soon as some tasks are done. So it's a little tricky here. Regression testing, some may think, comes 1 or 2 sprints later. However, regression testing should start the moment that some tasks are done. In SpecDD, if we're in a current sprint and we find something and we're working on a task, the QA floater starts the regression testing right then and there. They're the ones that can take that task. The developer thinks he's done. The QA floater can take a quick look, verify, and if they find something wrong, well, that's your regression testing. And the last option, perform testing automatically and manually, that could also be true. It's not necessarily a wrong answer. But really the best answer we're looking for here is number 3. So here's a screenshot of a QA test event as depicted within our DevSuite tool. We have our story 5-3. That's how I know it's a story. The spec was 5. This is the 3rd copy of it. So we use that. Sorry, we don't use that. It's linked to the test library. So we know that these test cases were derived from the same spec as this story was copied from. And then so this test event contains 2 testing templates. And you see the states and the owners of this testing event. So here we have a typical SpecDD workflow end to end. Now it's not that different than our pretty standard workflow. So you have your new state, go straight into to be assigned. Your in progress, which should be the bulk where most of your tasks lie. Not just tasks, but also other items that need to be worked. And then from here we branch off to 4 states that aren't as typical. And these shouldn't hold as many tasks at any given time. You have your requirement review on the left side. A requirement review, it's more for the developer to understand the requirement and to take a quick look if needed. It's also to help the product owner further review and refine the requirements. And hey, maybe they discover that it can be closed or dropped. Then on the right side, we have our QA review. So the QA also needs to review this particular requirement, make sure that they understand it before they create their testing based off of it. And then within the in progress to the QA floater verify, this is within the small development cycle for the sprint. The QA floater takes a quick look at the items that the developer thinks are finished. They can accept it and close it and done, or the QA floater can send it back to the developer in progress. And if the verify has failed, well, that's the main purpose of the QA floater. And while the QA floater is verifying it, it's also considered QA testing. So the QA tester, the QA floater testing on the side may fail it, or if it does pass, then they'll close it out. So a quick look at a distribution report. This was just taken out of one of our existing projects. So notice again, the bulks should always be in progress. We want people to be working on the items or completed the items. And then the minority states are the QA review, requirement review, QA floaters, and QA testing. Question number 6. How do QA floaters affect the burn down report? How do QA floaters affect the burn down report? They run testing and update time remaining of test tasks. They update it themselves. QA floaters run the QA child tasks and submit defects. Choice number 3, they run QA child tasks and help to adjust the time remaining. Or number 4, without QA floaters, burn down normally go faster. So first answer choice, they run tests, true. They update the time remaining of the test tasks. That part is not true. The QA floater themselves will never update the time remaining directly, especially of the test tasks. The time remaining of the test tasks are not incorporated in the burn down report. Answer choice number 2, they run the QA child tasks, true, and they submit defects. While true, it doesn't really affect the burn down report. So it doesn't really make sense. Number 3, they run QA child tasks and help to adjust the time remaining. And both parts are true. They will run the child tasks. If they do find a defect, they submit it to the developer, which then may need to adjust the time remaining. So the QA floaters really do help, or they assist in changing that time remaining. They don't do it themselves, and they don't do it for their own testing tasks, but they do affect the developer's time remaining, and that's how it will affect the burn down report. And number 4, without QA floaters, the burn down normally goes faster. That is also true. So if the QA floaters are not there, then developers, they shouldn't. But many may, since they don't have somebody looking over their back and checking their every step, may just write the code and send it off without double checking, without verifying certain items. So that actually does affect the burn down report, making it go down faster. Next up, we have our release test plan. So this is simply a test plan for an official release or even any internal release. The QA team selects a set of test case templates to be included. This depends on which set of stories were supposed to be implemented. They define the quality standard. They may have to create runtime environmental variables, such as different platforms or different OSs, for instance. They define the resources for the team members. Person A can dedicate this much time, person B can only dedicate X amount of time. And they set up their automation testing tools. They also calculate the workload once they've figured out the items that need to be tested, both the automatic and the manual testing time required. The test cycle itself is simply an execution of the previous release test plan slide. Some or all test cases may be selected for the test cycle. Test tasks are instances of the test permutated based on the test case templates and the runtime variables. Meaning a test task simply takes the original test case and permutates it based on the runtime variables. So let's say I have an environment runtime variable OS. Okay, I need to test something for Windows 8, Windows 8.1, Mac OS X, and Linux. Well, my one test case now becomes 4. Now our dev test tool will automatically create those permutations, but the QA test team needs to keep track and realize that they have 4 items they need to test instead of just 1. So these test tasks are then assigned to the testing engineers, and the workload is calculated. Once each test task is executed, the defects found are submitted to the development space. Where? In the development space? The product backlog. Testing for previous sprints. Now, test cycles are continuously being created to test the finished sprint. But if you consider when the sprint finishes and when the testing cycle begins, you'll discover that there's either some overlap or something doesn't match up. Well, there is an overlap. The test cycles should have an overlap with the sprints. And that's something we'll discuss in a minute. But the defects that are found are submitted to the release backlog. And the workload is adjusted in order to address the defects earlier. And this leads to the release backlog. And release backlog here also means product backlog, same thing. Should be reprioritized often by the product owner. Just because a defect has come into the product backlog does not mean that it automatically gets assigned to the next sprint. It very well might, but the product owner needs to reprioritize often in order to determine where those should go. And he does that with a method for measuring the number of defects introduced by each sprint. With this measurement, he can also determine the quality of the code that's being written and the quality of the testing. Okay, so he can see, oh, this sprint A, something happened. How come we got 200 defects when all our previous sprints only gave 10? So in order to provide complete test coverage in SpecDD, we need to create a test plan for every newly finished sprint. And with those test plans, we need to be sure to incorporate all of the newly completed stories from that previous sprint. We retrieve the linked specs. We make sure we understand what the input was for this finished sprint. And we derive those test cases from those linked specs. In order to provide complete test coverage, we also want to make sure we find out all the related product functions. So we retrieve all the linked specs from maybe similar functions that were created in previous sprints. And we can export all of these test cases, apply the environment variables, and test as needed. And finally, we want to make sure to apply regression testing. Okay, so we want to select the related testing areas and be sure to execute all the runtime variations for those areas. The integrated development and testing process, this is one of the older slides for our training session here. And basically it just details out multiple iterations, the concept behind having multiple iterations for development and testing. Okay, so each cycle really turns. So when and where to assign defects. Now we know that if it comes out of testing, it goes into the product backlog. But then when do we take that and put it into a sprint? Well, that's really up to the prioritization of the product owner. But there is a little bit of strategy involved, and that's something that we offer with SpecDD that SpecDD can help you with. And this is the overlapping. So in typical methodologies, you have your development sprint. And as your development sprint finishes, on the last day it produces working software. That working software is passed to QA, and then QA can finally begin testing. When they're testing, what is development supposed to be doing? Are they just supposed to be sitting around waiting for those defects? No. Development typically starts the next sprint. So now we have a complete overlap, and QA is one entire sprint cycle behind. And that's kind of a waste of time. So in SpecDD, here's what we suggest. And we find that it works a lot better. The overlap covers halfway into the sprints. So you have your development sprint, and as they're developing and they're coding, at the same time, remember, we have those QA floaters kind of floating in there helping with the testing. But near the middle of the sprint, when the working software is really started to getting to become created, it's being developed and it's reaching that substantial state, we can begin our first test cycle. Therefore, the working software needs to be delivered on a daily basis to the QA testing team. QA and development, they both have all the information they need. They both have all the linked requirements and the specs. They both have all the original ideas. They both know what it is that they need to create and what they need to test. So there's no reason why this overlap can occur simultaneously. So as the daily build, and this is where automation also plays a huge role. If we could automate that process, once the day ends, we have a piece of working software, it gets automatically built, it gets sent to QA. QA the next day can already begin testing on the previous day's build. Okay, so now we've gone from a whole sprint cycle delay down to a 1 day delay, a 1 day overlap. And that's really beneficial when you're trying to implement Agile. That really helps you stay Agile. So then, when these tasks get finished, QA can test on the next day. They can find defects. They can put those defects straight back into the product backlog, and the product owner can start reviewing them. And he can reprioritize, and he can see if those defects, if they are of a high priority, they can go into the next sprint. Previously, with the older Agile methodologies, or with different Agile methodologies, that defect would have to wait until the following sprint. So right there, we've saved 2 to 4 weeks, depending on your sprint cycles. And continuously over time, this really helps with the speed and the efficiency, as well as the integration between the development team and the QA team. And one of the last slides here, submitting and closing trend of defects. So this is a report that DevSuite produces based on all the data that it aggregates within the tool. And it basically shows the trends of how many defects have been submitted and how many defects have been closed. So the submission indicates how well the QA testing team is doing. And as a byproduct, also showcases maybe the standard of developing that your developers have. And the closing trend is how fast your development team finishes, along with simultaneously how fast the QA is testing it again and closing them out. It's not necessarily a one-to-one. Each submission should follow each close, but within the specific sprint, it might not occur. And lastly, we'll have a short topic and presentation. It's kind of an open-ended discussion. We want to see what your thoughts are on how to effectively integrate quality and development. SpecDD, we really have some newer ideas, and we think those are really the industry best practices. But let's hear your thoughts. How would you manage testing during development sprints? Would you wait until the end of the sprint? Would you do it at the beginning? Would you do it start both on day one? Illustrate your thinking. The relationship between developing those tasks and the test cases. And maybe the communication of the developer and the QA tester. Would they both work on the test cases? Would they both work on helping writing the code? How would they work together? And second part, explain how to perform regression testing. How do you currently do it in your company? And how do you envision your company doing it? Maybe find some similarities or differences of the test cases for the future testing. Okay. Food for thought. Thanks for joining me for this session, and until next time, goodbye.